Okay, so I'm going to try not to trip. I have this cool stand where I can go up, and then I can go down and walk around. So we'll see how this works out and what I end up doing. But I want to tell you how excited I am to be here in Bengaluru at my very first PGConf India. I've given this talk before in a couple different places, and I hope you all enjoy it. It's a beginner's guide to partitioning versus sharding in Postgres. And before I dive in, I'm curious, how many of you work with Postgres today, either in your jobs or even as a hobby? Raise a show of hands. Okay, so most of you. All right, how many of you have used partitioning either now or in the past in your jobs with Postgres? Okay, so a smaller number. Cool, that's good. That's why you're here. And then what about sharding? How many of you have used sharding with Postgres? A smaller number still than partitioning. All right, thank you. Super helpful. All right, so let's dive in. My name's Giordano, and I've been involved with Postgres since about 2017, when I joined a small San Francisco-based startup called Citus Data. And we subsequently got acquired by Microsoft, and I'm still there, although I don't work on Citus as much anymore. More of my focus is actually on that kind of bottom box here. This is a simplified version of a very detailed infographic that I include in a blog post that I publish once or twice a year. It's really more like once a year, but my boss wants it to be twice a year, so there's that. It's a little tension. But in that blog, I go through all the things that are happening with Postgres at my company, but my focus is on a lot of Postgres community work. And the reason this talk exists is a couple of years ago, I want to give a shout out, I'm going to get the pronunciation right here, to Tomasz Gintoft, who created this community blogging day, and the topic was partitioning versus sharding. It was part of this PGSQL Friday program that Ryan Booz had started. And I thought, oh, well, I know a thing or two about sharding. I could probably write a blog to contribute to that, and I want to learn more about partitioning. So I wrote this blog, and it turns out it was really popular. And so I thought, oh, okay, well, maybe I should turn it into a conference talk, which I did, and that's why we're here. So in this beginner's guide talk, we're going to go through 8 chapters. And before we dive in, well, no, let's just dive in. Let's just go. And the chapters cover things like what is partitioning and what is sharding, as well as, like, can you use them together and how are they different from each other? And then why partitioning can help improve your query performance, and specifically, when does it do that? In what situations? Same 2 questions for sharding. Why does sharding help improve query performance, and when does it do that? All right, so chapter 1 is what is Postgres partitioning? People who know me know that I use a lot of analogies. So here we go. Does anyone, I don't even know if you have this kind of tree here in India, but maybe you do. Does anyone recognize it? It's a redwood tree. So I live in California in the United States. We have lots of redwood trees. And so imagine this huge, beautiful redwood tree is like a big Postgres table full of really important and interesting data for you. What if we could split this tree, this really big Postgres table, into many smaller logs and only work with the logs that we need? Maybe I need to make a beautiful piece of furniture as a wedding gift for somebody, and I don't want to have to, after chopping down the tree, to process all the wood. I just want to pick the pieces that matter and focus only on those. And that's kind of what partitioning does for you. It enables you to split that large Postgres table, that big redwood tree, into smaller tables that are called partitions. And yeah, so that's what these smaller logs are meant to represent, are the smaller tables called partitions. And it's a built-in feature to Postgres. And those of you who've already used it already know that. Now, when I was researching to write the blog post and then create the talk, I found this wonderful blog post written about 2.5 years ago now. I think it's due for an update. And it was written by Brander, And I put a short URL in the bottom left if anyone wants to check it out. But what I really liked about it is that it itemized all the improvements to partitioning that have happened over the years, starting with Postgres 10. And it stops at Postgres 14. But I'm going to look at Amit for this, who just gave a lightning talk yesterday. And he talked about an improvement to partitioning that has been committed for Postgres 18. And is it safe to say there have been partitioning improvements in Postgres 15, 16, and 17 too? Yes? There might have been. OK. I will go further, and I'll just be bullish on it and say there probably were. There were probably some. And so anyway, that's why it would be great to get this blog updated. But it's super useful for me in doing the research. Now, if you're wondering, if you haven't used partitioning yet, and you're wondering, well, what are the benefits of using partitioning in Postgres? The first is, and the major one that people talk about a lot, is that it can improve your query performance, particularly if you only need to query a subset of partitions, and that subset of partitions can be held in memory. Well, you can imagine how that would improve your query performance. And then for auto vacuum can run in parallel across partitions, and so that can help you avoid the auto vacuum cannot keep up problem. And it can also help with optimizing your storage as well. You can imagine taking older data that's seldomly accessed and putting that on big, slow disk, but taking your really hot, active partitions and putting them on fast and expensive SSDs. And then when it comes to bulk deletes, you can avoid having to scan an entire big table in order to delete data, and then you can just drop that particular partition. So it's a lot faster there as well. So these are some of the main benefits that people talk about with partitioning. Now, back to that Brander blog post that I love so much. There is some text in it in green font that I want to read out loud to you, because he just has a way with words. But he wrote, in Postgres, trying to remove old rows from a large hot table is like flitting with disaster. But with partitions, deletion becomes a simple drop table. And I just found those words to be really, really powerful. But you have to remember that partitioning is not a panacea. It is an advanced power tool. And you have to put a lot of thought and careful consideration into how you're going to use it, and notably how you're going to maintain it, how you're going to maintain all those partitions. So with declarative partitioning in Postgres, there are 3 different partitioning methods. And the first is partition by range. And that's really good for time series data, IoT data. It's good when you have an even distribution of data, which in time series is often the case. And then there's partitioning by list. And people will use that. Good common examples are when you have a list of companies or company divisions or countries, it might make sense to partition your data in that way. And then I often think of hash partitioning as something that you would use when there isn't an obvious partitioning key. When range doesn't make sense, it's not time series data, list doesn't make sense, well then you might use hash. But in addition, with hash partitioning, it can also help you make sure the data is more evenly distributed, so you don't end up with a partition that's 1,000 times bigger than other partitions. All right, so how many of you like Taylor Swift music? Show of hands. All right, the people who put their hands up, they put them up aggressively. Did you see that? Right here in the front row? Varun, I love that about you. Okay. Yeah, I haven't noticed a lot of overlap between the Postgres community and the Taylor Swifties out there, and I don't understand why. I think there should be more of an overlap. When I was at PGConf in Prague and I asked how many people had been to one of the Eras concert, and there were about 300 people in the room, and I think I got 2 hands raised, which was so depressing. But anyway, we are going to use a Taylor Swift example here today. And let's say we needed to track monthly concert revenue for some of her concerts. And these are the 4 steps that you'd have to go through. First, you decide on the partition method you're going to use. And then you have to decide on the partition key. From there, create a partition table. And then you create the partitions themselves. So in this case, because we're looking to capture monthly revenue, we want some kind of time-based partitioning. And so we're going to want to use the range method for partitioning. And then from there, we need to create the parent table or the partition table. And so I put the code block up there, and the thing I want to point out to you, the thing that's different, it's like a normal create table that you would all recognize. But what's different is that you declare the partitioning method, and you can see that on the last line there where it says partition by range. And then you also declare the partition key, which is in the last line as well. And in this case is sale date. All right. So now let's go ahead and create our first partition, and we'll do that for June 2024. And the thing I want to point out there is that the lower range is inclusive, and so June 1st you want to include data from all of that day, but the upper range of this particular partition is not inclusive. So that's why it's set to July 1st. So we'll capture all the revenue up until the day clicks over and it becomes July 1st. All right, so we'll go ahead and create 3 partitions now. We're just going to do 3 months. So June, and then July, and then August. This all makes sense, right? Yes? Feedback? Somebody? Yeah, okay, cool. Awesome. All right. So, and we spoke about bulk deletes earlier and how that is one of the benefits of using partitioning. And so I wanted to show you how simple it is to do a bulk delete here. If you wanted to delete all of the June data, it would be as simple as doing this drop table. And the rest of the partitions don't need to be scanned. If you had a big table, you wouldn't need to scan the whole thing. You just drop that partition, and it happens pretty darn quickly. So that's how it would work. But again, reminder, this is a beginner talk, but partitioning is not a beginner tool. Partitioning is not magic. All of these partitions that are getting created or deleted have to be maintained. And in fact, you can't ingest data into a partition that doesn't exist yet. So, you know, when the new month comes across, that partition better be there, ready for the data to be uploaded. So there are 2 popular open source Postgres extensions that I want to give a shout out to that people use a lot. And the first is called PG_partman. And that makes it easier to manage partitions. And then PGCron. Oh, so wait, how many people have heard of PG_partman? Show of hands? Okay, a few of you. How about PGCron? I expect to see more hands. Okay, good. A few more hands there. So PGCron is like a cron-based job scheduler that runs inside the database. And it will make it much easier for you to schedule all the maintenance that you need to do in terms of creating or deleting partitions. So shout out to both of those. All right, chapter 2. What is sharding? So I just threw a bunch of small squares on there. One of the things that happened to me when I joined Citus, we had a lot of diagrams on the whiteboards in the office and, you know, in the documentation and in the PowerPoint slides, and wherever I looked, people were diagramming, you know, a sharded, distributed Postgres cluster. And typically, there were small little squares that represented the shards. And so then I started to see shards everywhere. I would be in an airport shop buying some water, and I'd see a box of Kleenex, and it'd have little squares on it, and I'd think, oh, those are shards. Or I'd look over there at the wall, and I'd see those diamonds, and I'd think, oh, that's like sharding. I saw shards everywhere I looked for a couple of years now. So anyway, that's why I depict it that way. But in the diagrams that I'll show you, they'll have these small squares, and a shard is just like a smaller table. Took the big Postgres table, split it into smaller tables, which we'll represent as these little squares, and they get distributed across multiple servers. And that's kind of the key thing, is with sharding, most people shard with the intent of distributing that data across multiple servers, so across multiple nodes in a cluster. And so, and before I move on and go back to the analogy with the big redwood tree, when I think about a concept or a person who has multiple names, it can be really confusing to recognize that those multiple names all mean the same thing. So I just want to point out that sometimes when people talk about sharding, they might not use the word sharding. They might talk about distributing Postgres, or they might talk about scaling out horizontally. But typically, those mean the same thing. And they're talking about sharding when they use those other terms. And the reason there's a rose on this slide is whenever I think about this dilemma of something having different names, I'm reminded of Romeo and Juliet. and the famous Shakespeare quote that says, "A rose by any other name would smell as sweet." So, sharding smells sweet? Is that the takeaway? I don't know. Let's keep going. All right, so if we go back to that previous metaphor with a big, big redwood tree, beautiful, taken in California, if you wanted to split it into smaller pieces so that you don't have to work with all that wood and you just have to work with what you need to focus on right now, and you want to distribute it across, say, a forest, and somehow maybe it would look like this. This is probably the worst Photoshop job and the ugliest slide you will ever see in one of my presentations. But I was actually talking the other day with a PM at Microsoft named Adam Vogt. He's one of the PMs who works on the Citus open source project. And we decided that it would make sense if we did this, like just made this improvement. So imagine if you have different campsites in the forest, and then you take those collections of shards and you associate them with the different campsites. So the campsites are like multiple servers that you have. And so this is my analogy here. All right. So there are 3 common ways that people do sharding. They implement sharding in Postgres. And the first is often called manual sharding. Or some people refer to it as application layer sharding, or sharding at the application layer. And I'm going to have a sip of water. I probably didn't need to tell you I was going to have a sip of water. You probably would have figured that out. All right. So that is one way. And what happens there is the data, what would have been in one big honking database with all these big tables, is split into multiple smaller databases. Like, that's how you set it up to begin with. And then the application has to keep track of which database to query. Where is the data that we're looking for that we need to go query? So that's manual sharding. The second one, and this is the one I know the least about personally, but that's where you use partitioning and foreign data wrappers, Postgres_FDW, and you can use hash-based partitioning, and then basically each partition is a foreign table, and perhaps set across multiple nodes and servers and things like that. That is absolutely a way that some people have implemented sharding. Some people have called it poor people's sharding, and I don't think that's fair, but I have heard it called that in the past. And then the third mechanism is using the Citus open source extension. And that is, sorry, keep hitting that. That is what I'm most familiar with. So that's actually what we're going to focus the talk on. We're not going to cover all of these 3 types of sharding in Postgres, but we'll focus on comparing using Citus with partitioning. Now, when I was first giving this talk, I was talking with this brilliant engineer named Dirk van Veen. He works at Adyen, and he's actually a prolific Postgres conference presenter too. So you may have seen some of his conference talks online. And he's given several brilliant talks about partitioning as well. So if you want to know more, Dirk van Veen is someone you could look up. But we were talking about these 3 different sharding techniques. And he said, the bulk of the work is done by very different people in each of those scenarios. And it was such a good point, I thought it was worth a segue, and I thought it was worth putting up here. So in the case of sharding at the application layer, or manual sharding, the leftmost one, the application developer has to carry a pretty big burden. Right? They have to keep their application up to date as Postgres versions change, as new features come available. They have to keep maintaining it. There's absolutely a bit of a distraction from the application itself to manage all of these different databases and how the app interacts with them and queries them. In the second case, with partitions and Postgres FDW and foreign data wrappers, the DBA has a big maintenance burden. So they're carrying a lot of the load to make that work. And in the case of Citus, it's actually the Citus engineer who's carrying a lot of the load as new versions of the extension are developed and as it evolves, as new features and capabilities are added. So I just wanted to go down that segue with you. All right, so today's talk, like I said, we're going to focus on using the Citus open source extension in order to look at these 2 technologies together. And I don't know if this diagram is useful. It is for me. On the left, you can imagine that blue box as a single node and those squares within it as big, big Postgres tables. And then you can imagine in the distributed Citus database cluster scenario on the right-hand side, all circled, each of those big squares is a node or server, and then all those little squares inside are shards. So those bigger tables have been sharded and distributed across the multiple nodes in the cluster. And those little tiny pink tables I just had to put reference tables on there because actually Citus supports distributed tables, local tables, reference tables. There's more complexity to it than that. And probably I should have removed them because then I could make it even simpler. So this is the beginner talk though. The Citus extension does a lot more than sharding. It supports all those different kinds of tables. It co-locates data. It has a shard rebalancer built in. It has an adaptive query planner. And this is the beginner talk, so we're not going to go into all of that. But I just wanted to throw a URL up on the screen if any of you were curious to dig in more. That particular technical README was written over a year ago now, but it's absolutely still applicable. There might be some new features and things like that, newer versions of Postgres, but might be useful. Okay, so why do people use sharding? What are the benefits of it? The first is it can improve your query performance at scale. And why is that? Well, it's due to all the additional memory and disk and CPU that you get from having all these multiple nodes in the cluster. And you can also get parallelism as well. For certain types of queries, they could run in parallel on different nodes too, and that can speed up your query performance. The other thing that it does is it enables you to grow and scale. So a lot of times people will adopt a sharding solution almost before they need it, right? Because you don't want to be cutting over and migrating to a sharding solution at the moment you need it. That would be crazy stressful and obviously create performance issues for you. So it's that future-proofing of your database solution that people will adopt it for. And then it also improves the performance of auto vacuum, similar to partitioning, because auto vacuum can run in parallel across all the nodes in the cluster. So those are the three main benefits. And then I just want to point out that there are two ways to shard with Postgres. And if you've used Citus in the past, like years ago, the traditional technique is called row-based sharding. Although we didn't used to call it row-based sharding, but now we do because we now have a second mechanism. So you might be familiar with row-based sharding, and that's where you have to specify your sharding key, sometimes called a distribution column, here when you first create your distributed tables. And you have to create distributed tables for every table that you want to shard, obviously. And then the second way to shard with Citus that was introduced back in Citus 12, which I think was not quite 2 years ago now, is schema-based sharding. And that's actually a lot easier to adopt as a user because you don't need to pick a sharding key. Rather, you just take advantage of schemas that you're already using. But not all applications are using schemas in that way, so not all applications actually will adopt schema-based sharding. But it is absolutely there as an option, and it's a particularly good fit for multi-tenant SaaS applications. For a lot of them, it just makes more sense to use schema-based sharding. All right, so now, let's go into the third chapter. Can you use partitioning and sharding together? And you can see the answer. The answer is yes. And I don't know if this diagram is going to help, but I stole this from a blog post that a teammate of mine wrote a couple of years ago. And on the left-hand side, that tall rectangle, you can think of it as a single node, and each of the smaller rectangles within is a partition. So this is a really simplified example, because where are the other tables? Why is there only one table on this example? But yes, you can shard partitions, and that's what the right-hand side is meant to depict, where each of those partitions has been split into smaller and smaller tables and then distributed across multiple nodes in the cluster. So you can use them together, which is cool. And then before I move on to do a comparison between partitioning and sharding, which might be helpful, I want to point out that because there is so much management of partitioning, that the Citus team created 2 UDFs. UDF stands for a user-defined function in Postgres, and they try to make it easier to use Citus sharding along with Postgres partitioning together. So the first one is create time partitions that'll enable you to create as many partitions as you need for a given time range. And the next one enables you to drop all partitions that are older than a particular point in time. So I just wanted you to know those exist. Now, let's do the comparison of how partitioning and sharding are different. And so what I'm going to do is use this comparison table. On the left-hand side, I'll itemize all the different aspects and attributes that people I talked to thought were interesting and thought should make it into this table. And then we'll have 3 columns. The first one will be Postgres native partitioning, and the second one will be sharding with the Citus extension. And in the third column, we'll look at how partitioning and sharding being used together, how it rates. And I'm basically going to score partitioning versus sharding versus using the combination together against all of these attributes. So you can think of this as almost like a report card in school or something like that. And if the circle is green, that's good. And if the circle has got white or yellow in it, well, then that's not as good. So in this case, partitioning is clearly built into Postgres and sharding. Citus is not. Citus is an extension of Postgres, so it's getting that green circle, but obviously partitioning is not an extension, and the combo is getting these half white, half green circles. Partitioning is typically primarily used on a single node. Obviously, I mentioned earlier that you can use partitioning with Postgres FTW and foreign data wrappers in order to distribute it across multiple nodes, but most people use partitioning in the context of a single server, so that's why that's got the green circle. A multi-node distributed cluster, that's why the Citus column has the green circle. Same with the combination on the far right of Citus and partitioning being worked together. Okay, dropping old data quickly, I gave you the example before of how partitioning just makes that so much easier. When your data is obviously structured in a way that the data you want to drop is contained within those partitions. And then parallel distributed SQL and DDL and DML, well, that's where Citus shines, so it's getting a green circle for that. And then obviously using the two together, you'll see that a lot of times that the two together gets a green circle because it's getting the benefit either from partitioning or from sharding. For partition pruning and shard pruning, you may not know what those mean yet. I'll talk about them in a few minutes. So in that sense, maybe this table is out of order. But I will talk about them. And both partition pruning is really valuable to your query performance, and the same is true with shard pruning. So that's why those guys get the green circles. And then I've already mentioned that both partitioning and sharding can speed up auto vacuum by parallelizing it. So more green circles. Better index cache hit ratios. Again, more green circles, right? Because they both are able to improve the performance. And automatic maintenance. That one is where partitioning gets a yellow circle, because there is a whole bunch of work that has to be done on the part of the DBAs or whoever is maintaining the databases. So it gets a yellow circle, and the combination is part green, part yellow for that same reason. And when you've got partitions, somebody's got to maintain them. You need a strategy for that. And then typically partitioning is range partitioning in particular gets used with a lot of time series apps and IoT, but I really regret putting that row on here because there's lots of other use cases where partitioning also makes sense, just because that's the one that's most commonly recognized. I don't know why I made it special and I put it there. And then multi-tenant SaaS apps, that is a common good fit for using sharding with something like Citus and distributing across a cluster. So that's the comparison table. Was it useful? Okay. I don't like to put it up there all at once because then it's just like an eye chart. It's just overwhelming and it's too much. So I appreciate your patience going through it line by line by line. All right, so now we're going to dive into the next chapter of the talk, which is why partitioning can help improve your query performance. And as I was talking to David Rowley, who's one of my teammates, he's a Postgres committer and contributor, and he's done a lot of work on partitioning in Postgres. This is something he just drilled home with me, is like make sure people understand why. I think that helps the decision about whether it's good for your use case, whether it's good for your application. So partition pruning is one of the reasons why, and it means that your queries don't need to look at everything. Your queries will only need to scan what you specify, so a subset of partitions. And so by definition, they're going to get faster. Now, I put a picture here of like pruning in the garden because I thought it would make it easier to remember the terminology, partition pruning. But I have a better description. How many of you like to eat sushi? It's probably not, well, Amit, you're going to raise your hand, right? Okay. I'm a big sushi fan, but it often comes with soy sauce, and it's really salty, and then I'm super thirsty that whole night. I desperately need water. I wake up in the middle of the night, have to go find some water. Well, imagine that situation, and imagine if I lived in a big mansion, ginormous mansion, like an estate that's like 30 acres of land, and I needed to go look in every room and figure out where all the water was in the house before I could satisfy my thirst. Well, that would be a lot of work. But imagine if I knew I could just go to this bathroom and this kitchen and find water, and I could ignore all the other rooms in the house. That's my analogy that I like to use for partition pruning. When you do things right, it enables you to just look where you need to look and not process, not scan the rest of the partitions in the database. All right, did you guys like that analogy? Sushi, being thirsty, not having to go to all those rooms? All right, I probably used too many analogies. All right, the second reason that it can be faster to use partitioning, or your queries can be faster, is because data in the same partition often has good data locality. So your query can then do the same job by loading fewer pages. And so, whereas if things weren't set up in partitions, your data might be spread out all over the place on disk, and so therefore the query response times might not be as fast. So it's the combination of partition pruning and data locality that really pay dividends in terms of query performance. And I can't talk about why without pointing out when. And what I mean by that is, just like when you bake a cake, going for another analogy here, you've got to have the right ingredients. If you don't have the right kind of chocolate, that cake is not going to taste as good. If you don't have the right kind of flour, that cake is not going to taste as good. What if your butter had salt in it? What if your butter didn't have salt in it? These things all matter. Well, it's pretty similar with partitioning. Partition pruning cannot benefit you if your query isn't smart enough to narrow itself down to the right subset of partitions. So there has to be a where clause in that query, and that contains some kind of conditional on the partition key, so that all the other partitions don't need to be scanned. So if we go back to the Taylor Swift examples, what if we wanted to know what the August revenue was from ticket and merchandise sales? All right? So if we look at this explain query, it doesn't have a where clause. It's missing it, which means it doesn't have the right kind of chocolate or the right kind of butter, or it doesn't have salt. The query is not going to be as fast as it could be, because what's going to happen is all of the months, all of the partitions are going to get scanned. And so you're not going to get that query performance benefit. And I've drawn a little rectangle around it just to point that out. The explain output there shows you that we're scanning all of those partitions that we created earlier. But we don't want to look at June, and we don't want to look at July. We only want to look at August. So in this case, this explain query does have a where clause. And as a result, when I run the explain, you can see that I'm only scanning the August partition. And I can completely ignore the other partitions, and that's when partition pruning really kicks in. You have to be smart about your queries. All right, so now let's talk about sharding. We're getting close to the end, which is great, because I know you all are exhausted after 2 or 3 intense days. But we need to talk about why sharding helps query performance. And my analogy here is, you can imagine, I think there's about 12 musicians showing in this particular orchestra, and I bet when they play together, the music is going to sound wonderful, right? It'll be good. But if you add in a choir and you double the number of musicians and instruments, you're probably going to have an even more performant and beautiful sounding orchestra. And so that's my analogy for the fact that more CPU, more memory, and more disk can improve query performance. The second is shard pruning logic, similar to partition pruning. Based on your choice of sharding keys, your queries, some of them, can focus on just specific nodes. So in this case, you don't need to go to all the campsites. You don't need to go to all those nodes. If you know that Tom is in campsite 5 and that's where you need to go, then your query can just focus its efforts there, and you don't need to make a round trip or any network hops to go to the other servers and to process the other shards. So shard pruning can also benefit your performance. So those are the two main things in terms of why sharding will help query performance. But the question is when, and this one, it might be fairly straightforward. I mean, if your queries are slowing down, your tables are getting big, your cache hit ratio has been going down, and those are signs that your application needs more memory, needs more CPU than it's getting, and that's when you can benefit from having multiple nodes in a cluster, at which sharding can enable you to do with something like Citus. So that's when sharding can help. All right, so what are the takeaways of this talk? They're actually fairly simple. I think you all will remember them. The first is that both partitioning and sharding can really help improve query performance for specific use cases. And people call them things like invaluable and lifesavers. Like some applications, they adopt partitioning, they adopt sharding, and they never look back. And even with the additional administrative work or planning or data modeling, people are absolutely thrilled because of the performance that they're getting. So that's a positive. The other thing to know is you do not have to pick between partitioning and sharding. If you need to use the two of them together, you can. The third takeaway, and this is probably the most important one, is that these are both advanced tools and methods, and planning is required. So it's not they're not beginner tools by any means. And then the choice of your partitioning key or your sharding key, if you're using row-based sharding with Citus, is really, really important. So people spend a lot of time thinking about that up front and figuring that out before they adopt either of these. And that's it. I put some names up there to say thank you to people that have helped and collaborated with me on putting together this beginner's guide. And I do have 3 favors to ask all of you. The first is, if you haven't checked out the Talking Postgres podcast, which I host every month, I would love for you to check it out. If you're a user, you kind of have to be a curious user, like who wants to know more about the team that works on Postgres and builds Postgres. So we've had some fantabulous guests up there. There's Postgres committers, Postgres contributors, people all over the map. Inside Microsoft, a lot of people outside Microsoft have come on the show. And it's more about the human beings who work on the project and giving you an understanding of how they got there, why they do what they do, and why it matters. The second is, if you haven't heard about Posette, an event for Postgres yet, it is a virtual event that's going to be happening in June. My team organizes it, and the schedule just announced. So if you're curious what the talks are going to be about or who the speakers are, it's all available on PostgresConf.com, so you can check it out. And the third is that if you haven't already done the survey at our booth that we were doing, I have about 10 pairs of these socks left up here that I will give to people, the first 10 people who come and show me that they've just done this survey. So it only takes about 3 minutes, and it helps me with the community work I do in Postgres and helps some of my teammates with their work on the cloud managed service. And finally, I just want to give a shout out to the organizers. This has been a magical couple of days for me. I've loved being here. I don't know about all of you. How many of you are here for the first time like me? A lot of people. Well, they had like a 25% or 30% increase. It's a big, big jump from previous years. So thank you for listening. I hope it's useful. You can always reach me online if you have more questions or want to talk. And thank you.
Perfect. Are there any questions? We've still got about a few minutes left. Any questions for Claire?
I usually run out of time, so I'm surprised we have time for questions. How did this happen?
how can sharding help in multi-tenant systems?
Can you put the mic a little closer so I can hear you?
How can sharding help in multi-tenant systems?
How can sharding help in multi-tenant systems? One of the things that Citus does is it co-locates related data. So you can imagine that all the data from all the tables for a particular tenant is often located on a particular node. So when that particular tenant's queries come through, Citus is smart enough on the coordinator node to not have to go out and incur all those network hops and look at all the nodes in the cluster, but instead to kind of focus those queries just on the node where that particular tenant's data is. Which is not to say you cannot have cross-tenant queries, which is not to say that you can't do analytics across all your tenants. You can do those things, but obviously then you're going to multiple nodes in the cluster and it's not going to get that particular performance benefit. Make sense?
Thank you.
Sure. Any other questions? I think we have time for one more.
It's again about sharding.
Can you make it closer too?
It's
Thanks.
about sharding again.
Sure.
So, as you said, there's a coordinator node and query knows where exactly data resides. What if that database itself has been corrupted and now, whoever is connecting, application connects to coordinator node, I think, and then it's been routed to the node where the data exists. What if that node itself is down or has some issue? So would there be any recovery or something that happened behind this?
A lot of times when people adopt something like Citus, they also care about failover, right? So I don't know if that's the kind of situation you're talking about where a node is down. And so HA is definitely something, particularly for multi-tenant SaaS customers, that they care about a lot. Something like Citus is available as part of Azure Database for Postgres Flexible Server, and HA is usable with it, and that would be kind of the way you would try to manage and avoid those types of scenarios. Obviously, if you're not using HA, then you're taking some amount of risk there.
Yeah, in case of HA, it's just seamless. It happens in the backend, right? We never know exactly what had happened, but
yeah, and that's something that isn't built into Citus. The management of failover and things like that, it's something that you get as part of the managed service, or maybe you're using Patroni with Citus, and Patroni does have Citus support, really good Citus support. So if you were doing it on-prem, you would use Patroni with Citus to try to deal with that. Okay? All right, thank you all so much. And if you've got your survey results, just come and get one of these last 10 pairs of socks from me, okay? Ciao. Do you want a pair of socks for being my room host?